here. We're on the final pillar for security. All right? It is a really important part of this domain to be able to correlate what's going on in the app as well as what's happening from a security perspective, because traditionally security products sit outside of the application. They make guesses, they sit at the perimeter, they're trying to figure out what's going on, and they often have to go to the app teams and say, hey, you know, can you pull your DevOps folks off? I got some questions for them. We've seen an incident. Or let me talk to the developers. They don't want to have that, carve out that time for it. So we wanted to bring a tool that brings them all together. Now, I've presented it to you guys before. So I'm going to go real quick over the intro part. So this is the problem, the core problem we're trying to solve. And that is that app and security teams sit in silos. They're not best friends. They're acquaintances at best. We want to see if we can get them even closer together and starting to collaborate to try to figure out, all right, if there is a problem, how can we move really quickly? Log4J made that so clear that if these teams don't work together, they're in a lot of trouble, right? How do you find out where your vulnerable instance of Log4J is? Well, you're going to have to go talk to the security team. They're doing all the scans. Great. What applications does that impact? Oh, now you got to go talk to the app teams and the ops teams. Cool. Are you going to give them an IP address for a host, or are you going to give them a service name? Well, wait a minute. All of a sudden, the communication starts breaking down. We see people still today trying to assess, are they protected or not against these Log4j vulnerabilities? That's nuts, right? There's a better way to do it. And the way to do that, in our opinion, is to actually get inside the application in runtime. Let's watch it executing while it's sitting out there in production. It's servicing customers' requests. And what else are they servicing? All right, is there attack traffic? Are there vulnerable bits of code? Are you using third-party libraries that have vulnerabilities? We want to do all of that in production. And that's a really hard thing to do, right? Being able to sit in production, have the app teams be okay with it, number one, and do it in a performant manner. So that's what we have built with Cisco Secure Application. And it's built off of our agent architecture. So the agent architecture means that we've got agents that sit on the end user side in IoT devices, browsers. We've got agents that sit with the code itself, agents in the operating system, agents at the database. All of these agents are collecting telemetry and helping to correlate activity from a performance perspective. And security typically would be layered kind of around the application. You've got your perimeter security with IPS, firewalls, WAFs, that's looking for all the bad stuff coming in. And then you've got your workload security products, and they're going to be sitting in the OS compute layer. But very rarely did anyone have any visibility and definitely no control inside the runtime of their applications, right? Where you have Java, .NET, your dynamic languages. No one's looking at that because it's hard to do and it's dangerous. You could break the application. And this is where, when I came from the security group and moved into AppDynamics, I was super excited. Once I saw what AppDynamics could do, already trusted by the app teams, already deployed and instrumented all these applications, we could just bake security right into it, right? And it skips over all those hurdles. Do I have to deploy another agent? No. Agent's already deployed. Do I have to get special permissions? No. Permissions already granted for APM. So you get past all of these hurdles that security usually bumps up into. In addition, you get a lot of benefit from being able to understand how the app is behaving, which APM was already providing. Now, whenever I talk about this product, I say, hey, we detect vulnerabilities, we detect attacks, we block attacks. Someone's going to say, I've already got something for that. I'm not interested. So be it, right? But let me explain why the runtime angle to doing this is actually really unique, and it's a big gap in most security and companies' organizations. So let's just take you through the life of a developer who's checking in some code. They built some new cool feature, and they've used some library to help save themselves some time, and it happens to have a vulnerability in it. When they check it into the pipeline, into their code repository, the first part of application security testing you're going to have is a SAST. Every development organization is using SAST of some flavor or form, and is looking for custom code vulnerabilities. You wrote sloppy code, you put a bug in there that happens to expose your application. So SAST will find that. It can happen when you check it in, or it can happen when you're building an artifact like the container image, like when you're finally pulling all the pieces together and you pull in all the components that might have vulnerability. The other place, the other testing that is going to occur is software composition analysis, or SCA. And this is looking for third-party vulnerabilities. It's also doing some license compliance checks, but we're going to focus on the security piece of it now. That's done also when you commit and also at build time, okay? Then you've got DAST, Dynamic Application Security Testing, which is different than the first two. So the first two have access to the source code. They can see exactly what was written. They don't see how it's operating, but they see how it was written. DAST treats the application as like a black box. It bangs around on the outside, pokes, trying to find holes in it. You can do that during your testing stage or after you've pushed out into production. after the deploy stage. But DASTs are resource intensive. They don't really know what they're doing, so they kind of just beat up on it and guess and keep trying. So it's not often used, and it's usually done on a periodic basis. Tuesday next week, we'll run our DAST scan. Great, everything's changed in like the last week. We've pushed like 5 more moves to production. All the results are invalid. So DAST can be kind of problematic, and they have no access to the code itself. And then you have IAST, interactive application security testing. And that's focused on what is the app actually doing? Let's watch the behavior, let's understand it, and see if there's anything that's indicative of being vulnerable behavior. What we felt like was the gap that currently exists in software composition analysis is there's no perspective as to what's actually running in production. Log4j is a prime example of that. We had customers who said, don't worry, we fixed everything in the pipeline. And then the IT ops team who was using Secure App came back to the board and said, actually, you might have fixed all of the code, but we actually have old instances that are still running that are vulnerable. And they were able to tell that without having to do any heavy lifting. The tool just kind of told them. So that's a huge gap in security posture. And then the next place is interactive application security testing means you actually see what's happening and you can do that in production. What is the app actually doing based on stimuli that's provided from the outside? You never really know what an app's going to do until it's actually used. So it's really important to get that out into production. So that's where we're focusing our energy. Now, if we move past vulnerabilities into attacks, this is where we hear often, I've got a firewall, I've got a web application firewall or a WAF, I don't really need anything else. Well, you need all of it, right? Defense in depth. It's okay to have some overlap. It is not okay to have a gap, right? A gap in the attack surface means a breach. So let's take a look, like firewall, obvious one there, we're blocking suspicious network traffic. Web application firewall, layer 7 aware, but they don't really know the application, they sit outside the app. And then finally, you've kind of whittled away all the really obviously bad stuff. Now you're actually touching the executing code, right, with this request. And we're going to be able to block suspicious code behavior. And products of this classification are called RASP, or Runtime Application Self-Protection. What's really kind of cool about this space is it doesn't have to be an HTTP request. There are lots of asynchronous events that happen in applications, like a file exists, entry in a database gets created, and that triggers some action. And insider threats are not going to flow through your WAF, right? Insider threats are sitting in your environment. East-west traffic will not go through a WAF. So RASP gives you a view and a perspective and control that you don't normally get. This is also an area that we felt was underserved, and this is where Cisco Secure Application plugs in. Now, I want to take you through the kind of the life cycle of an attack, so you can see each one of these components, what they are seeing, what they are observing when this comes in. So an attacker who wants to leave a backdoor, they're sending a serialized payload that's going to land on this application's vulnerable code and hopefully download like some malware, create a backdoor. So they send that request in. The firewall might say, hey, this is coming from a weird geo. I've not seen this IP address before, right? I'm not sure what to do with it. I'm going to let it go because I don't want to block legitimate traffic. Hits a load balancer decrypts it, sends it through your web application firewall. Web application firewall will say, this kind of looks like serialized data based on a signature. But I'm not sure if that's what the app expects or doesn't expect. So I'm going to let it through. Then you get to the CWP, or Cloud Workload Protection, sometimes CWPP, Cloud Workload Protection Platform. If you're paid by the letter in your acronyms, then obviously CWPP. This is going to see an inbound connection that's spinning up a process. Then it would say, okay, that same process spun up another process. But it doesn't understand, again, is that normal behavior? What was the trigger for it? RASP gets a really deep perspective. It says, hey, I'm seeing deserialization occur. So I've seen some kind of encoded data that's been sent, that's been decoded or deserialized, and then it's spawning a whole new process. That is definitely not something that should occur. And when I alert people on it, I can actually tell them, by the way, here's my service name. Here's the application area I'm part of. Here's the transaction that I'm servicing. You give all this rich context to it. Again, we thought was underserved, and Cisco Secure Application sits there. Now, to do all this really cool stuff, there's a lot of foundational technology. And I wanted to go through, because I think it's an important thing to understand, especially if you're not a developer by trade. One, runtime environments. I've been mentioning runtime a bunch. Runtime just means code is executing. Runtime environment is everything that sits around the code to allow it to execute. So this would be things like, how do you load your dependencies? How do you do memory management? How do you interface with the OS? This is stuff that a developer who's trying to build the next big unicorn product doesn't want to have to worry about, right? They want to just write some cool code that no one's ever written before and make $1 billion. So they're going to run their applications in these runtime environments using like Java, .NET, dynamic languages like Node.js, or Docker is even a runtime environment. Now you can have nested runtime environments inside of Docker, a container image. You'd obviously have Java app running or a .NET app running, Node app running. Now, I mentioned it loads dependencies. What is a dependency? A library. Really important to understand that libraries are used, just like runtime environments, to speed up the developer's life, make it easy for them. Libraries make it even easier. They don't have to go write a logging library. They use Log4J. You're like, whoa, that's super vulnerable. It is, but it's also a really amazing logging library, right? It's been built and refined over many, many, many years. I'm not gonna go rebuild a new one. I wanna go write my billion-dollar idea into my mobile app, and I'll just use the logging from here. So that's why libraries are used everywhere, and if you find a vulnerability in it, the impact, just like Log4j, is really widespread. All right, then we also lean on instrumentation. And this is a technology that is used by APM vendors all around, including AppDynamics. And this is part of the runtime environment. It enables you to actually instrument an agent to see the code executing. And the cool part is you can intercept that code as it's executing. Call to a function, you can actually say, hey, what parameters are being passed? What's the resulting output from this function? Do I want it to continue this way, or do I want to alter some of the behavior? You have complete control of the application. And this also is a time-saving thing for the development team. You don't want the developers to have to go and build all of that into their application, right? You want the ops team to come in and say, I want to use that really cool AppDynamics product, and I just want to bolt it right on. So you can see here in the Java example, all you do is provide a Java agent and then put in the jar for the agent, and off you go. It's instrumented, it's looking at the code executing, and it can do that without any source code being touched. Next, stack traces, typically used for diagnostics, right? Developer writes some code, something breaks. How do I trace myself through to what actually caused the break? Well, stack trace will show you kind of the historical journey through an application as the code's executing, and better yet, will actually tell you the source file and line of code where the problem could have arrived, so that you could arisen, so that you could go in and say, all right, I need to go look at this particular file and see how this function is handling that code. Stack traces are a really important part of the runtime environment and used for diagnostics, which we also use in a unique way with instrumentation I'll talk about in a second. Next, APM. You guys are probably more familiar with this. APM is just monitoring for the health of an application. We use instrumentation in these runtime environments to say, all right, we're able to see this code executing. We know how long it took to execute, how long it took to service a request, how many times is it that method typically invoked. Are there any errors that we're seeing? We gather all that up. We build out a dependency map so we know service-to-service connections and relationships. And then we do something really unique. Within AppDynamics, we actually map out what we call a business transaction. And this is this concept, and Sundar was touching on it as well, this idea of, I want to understand the user's journey through the application. For instance, you go to checkout at a cart on Amazon, and you click that button to say, give me my goods. Behind the scene, there's like 20 different services, probably, maybe even more, that are actually enabling that experience. One, checking you've got payment, that you've got an address to deliver to, that the item's in stock, and then logging it into your order history. All of that is part of a single business transaction. We automatically map those out in AppDynamics, and we then do correlation for anomalies and root cause analysis on those violations against the health rules. For instance, the load suddenly skyrockets, the latency suddenly skyrockets, there's an error. And that's a really important consideration we're going to get to in a little bit around business insights to security. So I know that's a lot, right? A lot of security tech, a lot of foundational tech. And I want to pull it all together into a real world scenario. Log4Shell. In Log4Shell, this one was so bad. This was a 10 out of 10 in the CVSS score. You guys probably know that. I'm sure some of you, including me, lost your holidays around it. It was no fun. And it was no fun because it was so widespread, right? Third-party library, super easy for developers to use, but also it enabled you to download malware if the permissions were not set appropriately on your app. It allowed you to control the application code, inject your own code, modify data, grab credentials, you name it, you owned it, all right? So I want to walk you through how it actually happens step by step, so that we can then go back and talk about how instrumentation and visibility to libraries and all that with Secure Application can help in this particular scenario. So first off, the attacker is going to send in a payload to a vulnerable application, knowing that that application will then log that data. And you can see here, it says like $bracket JNDI. That's like a variable. It's like a string replacement, right? And that vulnerable server will say, oh, I've got to log this data. Maybe it's logging the user agents that connect, or it's logging a get parameter that's being passed. It sends it off to the Log4j library, and Log4j says, oh, JNDI lookup. I got to go check out and see what I replaced this string with. Oh, I have to go and ask an LDAP server. So I'm going to go out to this LDAP server to get the data to replace the string. This is an attacker-controlled LDAP server that says, oh, yeah, you know what you need to do? You need to run this code. So it serializes the code, sends it back to the vulnerable server, and the vulnerable server starts executing the code happily. And at that point, they own the application. So a secure application, if we go back to the instrumentation, right? Once you've instrumented for APM, you now have visibility to the code that's executing, the libraries that are loaded in that server, and we have a lot of information about what's going on. Number one, we know, hey, you're using Log4j, and it happens to be a vulnerable version. So in the case of like AppDynamics and customers who are using Secure Application, the moment this went public, within about 5 minutes, we had complete visibility of all of our production servers that were running a vulnerable version of Log4j. Customers are still trying to find out what applications are using it. We had it within minutes. Then, when that vulnerable Log4j tries to do the replacement to the malicious LDAP server, we can see that outbound request from the network. And what we do is actually say, hey, it's not just a network connection out to LDAP, and that could be totally normal operations. We're seeing it from a vulnerable line of code. So in a third-party library, that is vulnerable, Log4j, at a particular stack trace is what we're using. We're saying, we see it's traversing this vulnerable method and going to the network, we're going to go ahead and detect and block that. And then, of course, you want to know about it. You don't want it to just do it and not say anything. So we have alerting capabilities, plug into your SIM, so you can get notified when that actually occurs.
Question.
Yeah.
Were you blocking the process execution or the traffic?
We are very precise, right? If we block the whole application, we couldn't sell a product. Hack teams would not allow it. So we actually just block a transaction. We throw a security exception.
Throw an exception on that. Okay.
That's right. On that specific request. So the very next request comes in. If the behavior is not against our policy, then it goes ahead and processes fine. And that block doesn't have any performance impact. I don't have the numbers in this slide deck, but like our latency.
As long as it's not going to crash the process, right?
Right.
It doesn't.
Yeah, so a security exception typically would not crash the application. You could handle that security exception yourself in your code if you wanted to as well. All right, this is a view of our controller dashboard. This is showing all of the applications that are currently being monitored. It's a very high-level view, like here's the errors that we're seeing, or everything looks fantastic. So from here, let's assume that Log4j hits, and you're like, all right, I need to know how bad is this problem. You're going to want to go in, take a look at security. Now, we could deep dive on individual applications, or we can look across the entire application landscape. In this case, we just want to know how bad is it. Are we even using Log4j? So now we've got visibility to all of the instances of Log4j in our environment. What's really cool about this is, and remember in the SCA example where you're looking at build time, or you're looking at your source code, you're saying, hey, I see it sitting on disk somewhere. I'm seeing it sitting there. I don't know if you're actually using it. Because we're in the code, we're saying not only is it on disk, that's just dangerous but not that bad if you're not using it. We say you're using it. We can actually see that you're actually using the vulnerable bits of the library as well. So the perspective we give is really about prioritization. You want to go find where that problem exists and fix the ones that are most dangerous first. And we'll give you all of that perspective from here. And we can see this top one has a risk score of 10. So that looks pretty scary. As I dive into this library, we actually get a view into all of the vulnerabilities that exist within this library. And we can see there's individual remediation guidance for each one of the vulnerabilities. Why, might you ask? Why not just upgrade to the latest? That could break, right? If the APIs change, you might have to refactor your entire application to deal with upgrading that library. So you want to make small incremental changes to remove the risk that matters most. And maybe you have mitigating controls for these lower ones, or maybe the lower valued ones aren't a priority because right now, your CIO or CISO has come in and said, everyone will remove 2021 44.22.8. Now, the other thing that we can do, remember I was saying we could see the lines of code executing the vulnerable lines of code. We have this reach, so we can say this vulnerability was actually reached, the vulnerable code. We know it was touched. In this case, we actually blocked it. So we detected this attack, we blocked it, and over here, we're actually giving you that stack trace. So when you go to the developers, you're going to say two things. You say, one, here is the library you need to upgrade to. And two, here's the path that they got there. Are you even supposed to be logging this information? A lot of cases, people are just kind of logging a little bit of everything and not really being very particular about it. So now they can understand how that arrived at that logging moment into Log4j. But that remediation will take time. So you need to buy them time. Oh, come on now. And how do you do that? You do that through the runtime controls that we can provide. So you can define policies here that control the runtime environment. So we use instrumentation to go in there and say, hey, you should not be able to access these files or this part of the network. And in the case of this Log4j attack, the first stage in the attack was to reach out to a malicious entity controlled by the attacker over the network. Now, to be really precise, we can say network access from all applications and all tiers is going to be blocked if a stack trace contains, I zoomed in so it's hard to see, but JNDI manager, which is the class, and then lookup is the method, right? And then we're going to go ahead and block it. Once you put this policy in place, you now have mitigated that attack entirely, and you can take the time to do the remediation, to do the testing that you need to do. We had a lot of customers who kind of raced just to upgrade, and it broke things, and then they had to revert back and test again. So this removes that as a worry.
When you're looking at something like this,
Yeah.
where you've got something that hits the application world,
Yeah.
hits the security world, and we're all kind of from a network background.
Yep.
Who is kind of the intended person that would be managing and going into that? Is this something that you're primarily expecting a security team to do, the app team, the network team, server team? Like,
Yeah,
because
it covers all.
It
right?
touches a lot, and
Yeah.
I mean, one of the kind of the recurring themes is always, it's that guy's problem.
Right, totally.
So, if you were going to walk into an org and try and sell this, who would you talk to first?
Okay, so Cinder was talking about full stack observability, kind of like that perspective of all the layers of the stack, right? It matters, right? You don't want this, you want, kumbaya moment, everyone comes together. And so this tool is actually designed to create that kind of kumbaya moment. We believe that IT ops would come in, we actually have a prime example of this, where IT ops went in and went to the board I mentioned before and said, hey, we actually have this running in production, Log4j. The development team said, we fixed it on our side, it's not our problem. They pointed to someone else, right? So multiple personas use this tool. We've got AppSec looking for the vulnerabilities in it in the libraries. You've got SecOps coming in to define the policy. And you've got IT ops doing the overall monitoring for the health of the application. And then once we merge into the beautiful AppD cloud world, right, then you start adding in all the other layers, right? We start bringing in the personas that are focused on the platform teams, like on the infrastructure and the network and all that. If we don't build tools and create workflows that bring those people together, then at the end of the day, no one's really benefiting. Last thing I want to talk about is a hot off the presses. So I did show you the reached vulnerable code. That's a brand new feature, by the way, just released this month. Business Insights is rolling out today. It's in all regions except the US. We're working on that piece now. And this is a super important part of our vision. All along, when I set out to start building this product 3 years ago, this was the goal. So the goal was, can we start correlating these security insights to the business? Why? Just like Cinder's saying, do I want to go spend my time trying to fix or hunt down a problem over here that has very little impact to the business, right? If AR is not going to be impacted by it, maybe I don't care about it. And when you look at security, typical organizations will have thousands, literally thousands of vulnerabilities that are sitting out all the time. So there's always plenty of work to do, but not enough folks in development to fix it. So prioritization is key to make sure that they're working on things that are the most important. Now, earlier I was talking about business transactions, where can you correlate across many services the end user experience to, for instance, check out of a cart. Imagine if we could take all the security insights that I've shown you and correlate that to that business transaction. And you end up in a world where you can do some very cool things. So here's the dashboard for Secure Application. We're going to drop into business transactions. And from here, there are 4 business transactions shown here, right? We have internal batch processing, cart checkout, address update, price lookup, internal batch processing. There's no exposure to customers. Maybe there's no PII data in there I have to worry about, no customer-facing data, but its risk score is a 10. So that would be based on typical security practices. 10 is really awful. Let's go run and go fix that. That's true, but a 9.8 is also pretty bad. And this one is in the cart checkout service. And I know that one is something that we care about. We are tracking business metrics and KPIs to measure the success of the business through APM for that particular business transaction. That's where I want to target first. So from there, we can go ahead and drill in.
Well, you're going through that. With how you were kind of talking about how you might prioritize things.
Yeah.
Is there a way in here where you could kind of put in your own weights?
You must have a crystal ball and reading the future. We do not have that today. We're going to drop in here to the cart checkout because we realize that one is extremely important to our business, even though it's just a 9.8 in the risk score. When we end up in here, we get a view of a couple of things. First thing we get a view into is all of the vulnerabilities across the entire business transaction. So in this case, this particular business transaction has many tiers in it, right? We list all of the tiers that exist and all the nodes in those tiers to service this particular request. And we identify all of the vulnerabilities that are there. We identify if that vulnerability has been reached, meaning someone's touched the vulnerable code. And then we also stack rank it based on the risk. So here, we're going to say, you know what, we want to get really precise in our prioritization. So we're going to go ahead and look at only critical vulnerabilities.
When you're pulling these, because it's hitting the flow, are you only showing the specific services on, if you have a web server, are you only showing like the part of that would be impacted? Or if there was another part of that server that was vulnerable, that's not going to show here because it's not in this process flow? Yeah, you would only instrument the code itself, not the web server that's running the code. And so you would know that it's that particular piece of code you need to go fix, or that service. And here, we want to get really specific. So what I've done is clicked on critical, 'cause obviously critical is critical. I want to know those. Also, my entry tier is my front end service. So that's the one that's exposed to end users. I want to make sure that I understand what vulnerabilities exist that is exposed out to the big bad internet. So then I'm going to again filter based on this highest risk list to my front end, which also has my highest risk. And I'm left with a really precise vulnerability, right? So I went from importance to the business to this vulnerability. And now I want to go even further and understand how do I fix it, right? So all the way from business risk to remediation guidance within a few clicks. So that if you're going to waste the developer's time, and I say waste because that's kind of the way they perceive it sometimes, right? If you're going to go there and say, hey, I need you to go do something for security, let's be precise and say it's going to have an impact on the business, and here's what you need to fix, and we've confirmed that it's actually happening in your environment. Kind of a bigger question, but going through and building a lot of that stuff out and like those business process flows, how much of that is automated within the tool versus how much do I actually need an app owner to understand what their app does? Yeah, great question. So on the APM side of the house, we will automatically detect those business transactions. There is some grooming involved if you want to get the most value out of it, right? Someone would go in and kind of label what this business transaction is. They would build their KPIs that they'd want to measure around it. There is some investment up front. From the security perspective, we kind of get to like piggyback on all that. So someone else has done the work, they turn on security, and we pull it all in automatically. So the moment we get licensed and enabled, everything I just showed you is already there. You don't have to do any configuration. So it's pretty seamless process. In the case of the auto detection of those business transactions, I would say that most customers know right out of the gate, like there's 5 things we care about, or I did 4, but 5 things we care about, right? And they go and they'll do the business transaction for those.